Welcome to the 23rd part of Spring Boot Kubernetes tutorial series. In this video, we're going to learn how to expose pods using services. In the earlier episodes, we have seen how we can use deployments to scale up and down the desired number of pods. So let's say you are building an application and then you are running 5 instances, like using 5 pods. So how do the clients reach out to your service when there are running multiple instances? So usually we use some kind of a load balancer to configure all those instances and then expose one unified IP address or domain name. So all the clients will talk to that load balancer, and then load balancer delegates the calls to one of the instance. So in Kubernetes world, the service object type plays that role of load balancer. So let us see how we can configure a Kubernetes service object and delegate the calls, API calls to pods. Let us take a look at Kubernetes service documentation. Here we can see a service is nothing but an abstract way to expose an application running on a set of pods as a network service. So how do we define a service? It is kind of a very similar to how we define a deployment, but here we can see the kind is service, and we are giving some logical name to our service. And then we have this selector where we are specifying any pods which has this label will be part of this service. When somebody set a request to this port, it's going to forward to one of the pods that are having these labels. So to understand it in a better way, here we can see the ports mapping. Here there is port number and then there is a target port. What does this means? This service itself is going to listen on port 80, and then once it receives a call, it's going to forward to this port number 9376 to one of the pods which has this label. So that's how it's going to forward to one of the pods. And to get an understanding of how this works, here we can see, let's say we have built an application and we published two versions of image, version 1, V1 and V2. And then assume there are two deployments. We created a Kubernetes object of type deployment, configuring the first one is having the label app to my app and then version V1. And then there is a second deployment where labels app is my app and version is V2. And you specified to run replicas, 3 replicas for this first deployment, and then there is a second deployment with 2 replicas. So now, how do we define a service that delegates to number of pods? So here, if you define a service with labels, selectors, app is my app and version V1, then any calls that you send to this service is going to forward to one of these 3 pods, because this service is going to delegate to any pod which has these labels. Whereas, let's say if you remove this version V1, and now it's going to forward not only to these 3, it is going to choose to one of the pod for among all these 5, because the service is going to select any pod which has this label app, my app, and here we can see all these 5 pods that are having this same label. So that is how it's going to choose one of the pod. Okay, so now coming back here, there are various types of services, and depending on what type of service you use, you can make it available for the external world, or you can make it available only within the cluster. So here, service type can be one of these following. The default one is ClusterIP, which is nothing but it is exposed as a service and is available only within the cluster. any public cannot directly access to it. Only people who are within that cluster network can access that. And then there is a second type, NodePort, which is kind of a similar to ClusterIP, but it also exposes an static port on the network. Okay, so you can reach to this service on the node port using the ClusterIP. And then there is a load balancer, which is nothing but when you are deploying your service on cloud platform, and you can leverage one of the cloud providers load balancer. And then finally there is external name, which maps to one of the DNS name to these services. So here if you are working on any cloud platform, you most likely would use any of these two, but here for our learning purpose we can see how we can use both of these. So in our case, we don't actually need to expose a Postgres database for the public access. So we can create a Postgres service with a default type of ClusterIP. Whereas if you want to expose your API, you can expose it using NodePort so that anybody can reach out to your API service, not only within the cluster, but from the outside cluster as well. And finally, obviously, we need to expose our UI application so that people can reach out to your UI application. And again, using NodePort, we are able to access from the host machine or from anywhere, but you can keep it as ClusterIP type service only, and then use ingress to expose it to the public. But let us see how we can use NodePort and then try to access these services. So let us see what we have for Postgres database. So here we have defined persistence volume claim, and then we define the deployment. So let us define a service for it. So here I am pasting the service definition. So here what we are saying, we are trying to create a object of type service, and we are giving a logical name of Postgres-svc. And then this is the default type. You don't need to specify type ClusterIP. By default it is ClusterIP type, but to make it explicit I am specifying this. And then here I am providing selector with label app to Postgres pod. So that is nothing but when we are defining our pod containers, here our pod template contains labels as app Postgres pod. So for our service, when we specify selector labels as app to Postgres pod, so it is going to forward any request coming to this service to one of these Postgres pods. And then the port mappings, we are again listening on 5432 and then forwarding that request to this target port of this pods. Okay, so that is how we can define for our Postgres. And now the important thing is, for our API, we have specified here what is the host name, right? So here we marked it as bookmarker config and use the key Postgres host, which is defined in our configuration as Postgres host is nothing but Postgres. But this doesn't actually work. Why? Because just like in Docker Compose, it is going to forward to service with the name. Like now that we have this name, this service name is nothing but Postgres SVC. So our API will try to forward to this name, but here we have specified only Postgres. So with this value, our API should forward to this service, which internally forward to our Postgres container. So in deploying any services, Kubernetes, when you try to talk to from one service to another service, the host name is nothing but your service name. Okay. If you are using services directly, that is how you can reference, or if you are using ingress, you can reference using that ingress exposed name. Okay, so in our case, from our backend API, we are talking to the Postgres database and we are referencing through our Postgres service name. Okay, cool. Next, let us expose our API also as a service. So here, right now we have our deployment only. Now let us expose it as a service. So here again we created another object of type service, and we gave a logical name as bookmarker API svc, and we are specifying it is of type NodePort, and selector, again this is nothing but our pod label. Okay, and ports, we are just giving a logical name, and then a protocol is TCP, and we are exposing it on service 8080, and the target port is also 8080. And the extra thing that is interesting is node port is usually the node port is between the range of 30,000 to 32767. Here you can see type node port. You can see the default is one of the port available in this range. If you don't specify anything, it's going to automatically allocate one of the available port within this range, but we are explicitly saying I want it to be available on 30,090. Okay, so this is how you can expose our backend API to as a service. Similar to how we expose our API, I have created another file to deploy our UI application as well. So here I have created a fourth file, bookmarker-ui.yaml, and it is very similar to our APIs. If you take a look at it, we are exposing we are creating a service with bookmarker-ui-svc, and we are making it as a node port. And if you remember, our front-end application is using NextJS and is running on port 3000. We are exposing on the same port and then specifying the target port, same 3000, but we are giving a node port of 30,080, and we are defining a deployment and giving a name, and then matching labels as bookmarker UI pod, which is nothing but our pod label. And then we are specifying the containers. Image is nothing but supersabrity / bookmarker UI NextJS, and then we are specifying the container port as 3000. And the interesting part is the environment variables. If you remember, while configuring our application, we have configured two URLs, because when it is doing a server-side rendering, it is using a different URL, and if it is running client-side rendering, it uses a different URL. Ideally, in production, you don't need to have these two URLs if you are using a logical domain name. But in our local, we don't have a logical domain name, DNS name. So that's why we are configuring two different URLs. So in a similar way, while deploying on Kubernetes kind cluster also, we have these two URLs, client-side API-based URL. The reason is, when we are exposing our API, we are making it available on node port 30,090, but some way we are going to expose this on port 18080, so that if there is a calls to our API from the host machine, it's going to use localhost 18080, whereas during the server-side rendering, it is going to talk to through container to container on the server side. So in that case, the logical name would be this service name. Here we have our service name, right? So this is the name that is going to be treated as our host name for the API. So it is going to be this service name and then port 8080. So we have all these services defined for both API and UI, and also we exposed Postgres also as a service now. But we need to take care of one thing. So earlier, when we spin up our kind cluster, we have exposed our port 80 and then 443. In order to access these exposed node ports like 3000, 30,090 and 30,080, we need to configure those ports here as well. This is specific to kind cluster configuration, but if you are using any other cluster like Minikube, you can access directly using the node port and then a port number. But when you are using kind, you need to expose this. And also there is no, as of now, there is no way to expose a range of ports. That's why we need to specify each and every one in a separate way. So the container port, so for our API, our node port is 30,090, and then host port we are going to map it to 18080 protocol TCP, and then similar to this for our UI, we are going to expose that 30,080 to we can leave same, so it doesn't matter. So with this one, we need to destroy this cluster and then recreate it. So here we can go to cd kind and then destroy cluster, and then we need to create cluster as well. So it is going to take these updated parameters, and then it will make these ports available, which will forward the request to this containers 30,090. So basically this is nothing but our node port. We are going to access it from our host using localhost 18080. Same is the case for this one. So here our kind cluster is recreated, and it's going to take into account of these additional port mappings. So now let us deploy our resources. I'm going to go back into k8s folder, and I'm going to run kubectl apply all the manifest within the current directory. So it's going to deploy all these resources. So here, if we go into cluster from lens, so it's gonna take some time because it's a brand new cluster. It needs to download images and then recreate all these containers. All the pods are running, and here we can see our services. So here we have API, UI, and Postgres as services. Okay, now here we can also see in our kind configuration, we can access our API, which is running on node port 30,090 on the host machine 18080. So let us try to access that localhost 18080, and we have API / bookmarks endpoint. So let us call this. So we are able to access that, and we are getting this response. In the same way, let us try to access localhost colon 30,080. So this is nothing but our UI application. Here we can see we are accessing on the same port. And what happens is when we are accessing this application behind the scenes, it's going to talk to our backend API and then get the data. Okay, so it is working. So this is how we can expose our services using service of type node port. And when you are using kind cluster, you need to expose this to your host, and then you can access it. Let me quickly recap what we have done to expose our containers as our pods as services. So here, first we have exposed our Postgres database as a service. We have defined this new service, and then we make it as a cluster IP type service only, because we don't want anybody to directly access our database. So we're not exposing it to for public. And we have exposed our API as a service, but For this one, we are using type as NodePort so that we can access it on the ClusterIP and then NodePort. Here we have mapped our port, service port, and then target port, and then node port. So basically you can access this service using your node IP colon 30,090, but for easier access we have mapped this port to our host on port 18080. So and similarly we have created another file to deploy our UI application also, and we have configured everything similar to API, with the exception of how we are exposing these two environment variables. As we discussed in the previous section videos, there are two URLs we are using because we don't have a domain name or anything like that. So all the server-side rendering happens through this URL, whereas client-side API interaction happens through this URL. So we have discussed how it works in the previous videos. In order to access our NodePort services, we have made this change to kind config file, and in order to take this change effective, we have deleted the cluster and then recreated and deployed all the services. Now we are able to access both the API and our UI application on the ports exposed in our file. So that's how we can use our services. In the next video, we are going to see how we can use ingress controller to route the request to various services, and also how we can map using host names, things like that. So that's all for this video. Thanks for watching and stay tuned for the upcoming videos. Bye bye.